so since yesterday we covered exponentials, and we always want to do things in pairs as much as possible. So the reverse or the inverse of an exponential is a log. And so we want to take today, how do we solve the derivative of a log? Specifically, logs that are natural and logs that are have a different base. Okay, remember, what's the base of a natural log? E. Okay, the base of a common log is 10. The base of a natural log is E. Okay. Okay. If you have the derivative of any common log, any log that's not base E, so this is what the derivative looks like. Again, in the scope of this class, you just have to believe me, and then next year or in some future class. So you would want to imply parentheses around your U, and then the U shows up in a couple places. It's a fraction this time. So U shows up underneath a 1, so it's in the denominator of a fraction, followed by an ln of A. And A is found as whatever the base was right there. And then you finish with du dx, which is always our chain rule of whatever was in the parentheses that we started with. Okay, that's the rule for exponentials. So it has 3 parts, very similar to the exponential we saw yesterday, where it's got the first part and then it has an ln part. It's just that it's in the denominator instead of in the numerator. Okay, so you just have to remember that it has a 1 in it. The rest of it is still 3 parts, just like usual. So we can use that to find an ln derivative in the same way. So the ln derivative is going to have 3 parts. It'll have a part 1, a part 2, and then your part 3. So the first part will always be whatever is in the u part of the equation. For this case, it would be ln of something. And for an ln itself, we all understand that there's an implied e down there, so that would be an ln e. And then we would have du dx at the end. And we all would know that then that ln e would simplify to 1 later as we were simplifying. But there are 3 parts to that as well. So just like with exponentials yesterday, once you learn the 3 parts, you just got to get them in the right spots and then simplify. So I think we're pretty much just ready to try it. So this is a log. And so for you, you're like, okay, I know the format for a log. A log is going to be 1 over. There's going to be 2 parts to the log in the denominator. And then there's going to be times my third part of the log right here. So those are the 3 pieces. So I'll do this first one for you. It already has the parentheses there. And so that would be 2x minus 1. And then the next part's going to have an ln. And the ln would be of the number 4. And then at the end, we would have the derivative of what's in the parentheses, which would be the number 2. That's all the calculus part of it. The rest is all algebra and simplification. So then I would simplify this and I'd say, okay, the numerator is 2. I like to put my constant in the front, and I showed you yesterday that ln 4 is the same thing as 2 ln 2, that those are the same. And then 2x minus 1 I would put towards the back because it's not a constant. And that gives me a chance to reduce. So I can take the numerator that had the constant 2, and I can take the denominator that now has the coefficient of 2, and I can simplify them. So I end up with the simplified version of 1, and then parentheses ln 2, followed by parentheses 2x minus 1. And you just leave it in its parentheses. You don't need to distribute or do anything, just simplify it, leave it like that. Because later you might have to cross multiply, and it's just helpful to have it simple, like not expanded. That's pretty basic, right? Okay, I mean, you just got to get the parts in the right spot. And from there, we'll be doing tangent lines, we'll be doing parallel, we'll do perpendicular, we'll do all the same things we've done before. Okay, here you go. I would suggest always making sure if your log doesn't have parentheses that you rewrite it so that it does have parentheses before you get started. Okay? Does anybody want to try just the parentheses part of it for this one? Because it doesn't have parentheses yet. Maybe David can do that for us. David, could you write that just with parentheses so that so we're ready to do our calculus? You want to give that a try? So if I said, okay, log base 10 parentheses, all right, so what would that look like? Okay, so the 5x is the parentheses part, and then the half would go there. I feel like if you do that, you have a much more likely chance of getting the rest of the derivative right. So what's going to go first is the part that David rewrote into our parentheses. So it would be 5x to the half, and the half is on the outside of the parentheses, not on the inside. Then comes an ln. In this case, it would be ln 10 because of the base. And then we need to attack the chain rule. So as we do the chain rule, what rule are we using in the chain rule? Power. So the power says, look at the power first, and don't forget to subtract 1. So I'm going to take the 1/2, and I'm going to take 5x, and I'm going to subtract 1 from it. But because there's still parentheses that have the negative 1/2, I need an additional chain rule that helps me deal with what's still in there, so 5. So don't forget those parts. Okay, the old rules still apply. Then we'll put everything together. So my numerator, what do you identify as the only thing left in the numerator? 5, that's it. Okay, my denominator, okay, I recognize that there's a fraction of a half, so I'm going to put 2 in my denominator. The next constant is the ln of 10, so I'll put that first. I always put my constants first. Then I've got a 5x that was already in the denominator with a 1/2, and then I need a second 5x that comes down to the denominator also with a 1/2. So one of them was already down there. I'll identify that in green. That's this one. That was already in the denominator. And then I'll circle the other one in green, has to come down to the denominator as well. So that's going to simplify. When you multiply 5x with a half times 5x with a half, what do you do with the powers? You add them up. And so that's going to give me a 2, an ln 10, and then it's going to give me just a 5x to the first. 1/2 plus 1/2 is 1. Then I can reduce even further the whole 5 in the numerator, now with the whole 5 in the denominator. So I end up with 1, and I end up with 2 ln 10, and the only variable that's left is x. Can I pause? Any questions so far, Sean?
Hey, can you make it like 2x times ln 10?
Oh, you could. Okay. Sure. Yeah. The order there, I typically put my constants in the front, but ultimately you could put the x in the front if you wanted and put the 2 at the back, as long as, what you can't do is make that ln 20. Right? You can't take the 2 and the 10 and multiply them, but I've seen it happen. I've seen it where people put ln 10 and then they do times 2 like that and then all of a sudden they get sucked into thinking it's ln 20. So that would be one thing I'd say, don't do that. Okay, let's try another one. This one, thankfully, already has the parentheses in there for me, so I'm ready to take my f prime. So this is an ln. It still follows the same rules. Okay, Leela, you want to try this one?
Yeah.
Okay.
So you put the x squared minus 3x.
Okay, x squared minus 3x goes first.
And then you will do the ln as long as e.
Okay, so ln e.
And then you want to do the derivative of it.
Uh-huh.
So it's going to be 2x.
All right, so each part gets a piece. And then we say, all right, Lenny is 1. So my numerator is 2x minus 3. There's nothing I can factor out of that. My denominator, I can factor the x out, and I get x minus 3 when I do. But there's still nothing I can reduce. But I did want to just factor it out just in case there might be something I could reduce. Okay. In this next one, I wanted to show you it because although it does have parentheses in it already, there could be something that would be beneficial to you to do to those parentheses, even though they're already there, to make it easier for you in the long run. And so although the parentheses are there, can you think of anything else you might want to do to that? Go ahead, Sean.
Make it x to the negative 1.
Yes, I would recommend that you take this and make it ln of x to the negative 1 instead of 1 over x. Here's the advantage. You got to think ahead to when you're getting to the part of the chain rule. When you get to the part of the chain rule and you want to take the derivative, if you leave it like this, what rule will you need? You're going to need the quotient rule when you get to that point. If you change it into a different format, then you can use the power rule. And if I had my choice, I would much rather use the power rule than the quotient rule. So that's why I recommend that. So dy dx, 1 over, all right, we've got all of our stuff ready to go. Sam, you want to take this one?
So the first one is 1 over x.
Okay. So yeah, I can leave it. I could write x to the negative 1, or you could write 1 over x. Okay, next part.
One,
Okay.
and then negative 1 x to the negative 2nd.
Okay, great. All right, now you're ready to decide what goes in the numerator and what goes in the denominator. So we know that Lenny is 1. What's left in the numerator?
Negative x.
Okay, negative for sure, yep. And where did you get an x from?
The 1 over x.
Okay, this 1 over x in the denominator would be the same thing as multiplying by the reciprocal, which would be x over 1. So he's kind of thinking ahead and he's putting that x in the numerator. What goes in the denominator? X squared. Where'd that come from? That came from this one that needs to be moved down to the denominator. So the 1 over x gets moved to the numerator as a reciprocal, multiply by the reciprocal. The x to the negative 2 gets moved to the denominator. And then I have an opportunity to reduce that to negative 1 over x. Okay. All right, this is our last example for today. Find the normal line. So again, we're just going to be using the same strategies with a new derivative. So we want to know, if we're finding the normal line, we would want to know what the point is that we're working with. We need to figure out the derivative. And once we have the derivative, we should be able to figure out the slope. So the point is going to be 0, comma, and then 0 plugged into the function. So that would be the natural log of 0 plus 4 plus e to the 0. So ultimately, what does the y value of the point turn out to be? ln 5. Very good. Okay, ln 5 as we simplify that. 0 plus 4 plus e to the 0, which is 1. Okay, then we're ready to find our derivative. I'm going to erase slope for now just in case I need more space. So my derivative will have 1 over parentheses, parentheses times, I better not put the last parentheses on there yet. Okay. All right, Brandon, you want to take that one?
Yeah.
Okay. Okay, great. Times,
Times natural log of e.
good job. Okay, and times.
1 plus e to the negative 3x times natural log of e times
Awesome. Okay, great. He has all the pieces all in the right spots.
Good job.
Okay, now we've got a couple linees that we can make to be 1. And so we can simplify this to what is in the numerator versus what is in the denominator. So the numerator then is going to be 1 minus 3e to the negative 3x. And then the denominator will just turn out to be x plus 4 plus e to the negative 3x. And those e to the negative 3x's don't reduce each other, even though they each have 1, because this is an addition and subtraction problem. So then we're ready to plug in 0 to find our slope. So when we evaluate 0, we'll have 1 minus 3e to the 0 over 0 plus 4 plus e to the 0. And those e to the zeros will be 1, so I'm going to get 1 minus 3 over 4 plus 1, in other words, negative 2/5. And then you're ready to write your normal line now that you know the value. So your final normal line is going to be y minus the ln of 5, that's your y value. The normal slope will be 5/2, and then x minus 0 will be your the rest of that, x minus 1 term.